Turing machine is an especially simple kind of computer. This is how simple it is. The computer consists of a paper tape, which we can assume to be infinite in both directions. Maybe there's an assistant who's ready with extra stocks of paper. So if you're about to run out, the assistant adds more paper onto it. And it's divided into cells. And then the machine has a tape reader, which is positioned at all times at some particular cell. So here I'm going to indicate it with an arrow. And what the reader can do is it can detect when symbol is written on the cell where it's sitting. And it can erase that symbol and write down a new symbol. And it can move around one step at a time. And if you want to program a Turing machine, then what you do is you have each line of code have the following form. So each line is going to say, if you're in this current state and you're reading current symbol, then write new symbol and walk one step in this direction, which could be a null direction, and go to this state. So this presupposes that the machine is always in some state or other. And states are just natural numbers. So one assumes that a Turing machine always starts in state 0, and then its state changes as the machine does things and applies command lines. So here's an example of a command line. So say that there is an A printed on that cell. Then there might be a command line that says, if you're in state 0 and you're reading an A, then write down an X, advance one stage to the right, and go to state 7. So then what happens is the reader's there. It looks for a command line that tells it what to do. If it's in state 0 and reading an A, it finds this one. And in a properly written code, there should only be one command line that starts with a 0 and an A. And then says, OK, so replace the A with an X. Move one step to the right. And go to state 0. Sorry, state 7. And what it's going to do next is it's going to look for a command line that starts 7 blank, meaning if you're in state 7 and see a blank, then do blah, blah, blah. That's it. That is all there is to Turing machines.